So now let's talk about while loops. So while loops are a form of repeating something or looping through something while a certain condition is true. So let's just kind of write out the abstract form about how it generally looks like, and then let's go through some actual practical examples to get some intuitive understanding. So to start a while loop, we start with the keyword while, and you'll see here my coding environment colors it, which indicates that it's a certain keyword. And then we put brackets after a space, and then we put inside a certain condition, and then we put on a colon, and then inside, indented, we have an action, or we have several actions, so action 2, for example, and action 3. But the point is that we start with a while keyword, then we have a condition, and while this condition is true, we do the following. So we indicate that we want to start a loop by the colon. We do an action, and we're indented, which means we're inside the loop. Then maybe we do a second action, we're still indented, which means we're inside the loop. And maybe we do a third action, we're still indented, so we're still inside the loop. So I mean, you don't have to do only 3 actions, you can do as many as you like. You should do at least 1, or else your computer is going to complain, it's going to give you an error. But yeah, so the whole point is really that you have a certain condition, and while this certain condition is true here, you perform certain actions. So let's see this in action. Let's comment this out, and then let's just do some while loops. So the first thing that we'll do is we'll just print out the numbers between 1 and 10. And the way we're going to do that is we're going to create a variable called a counter. And so let's just create it, and let's assign our counter value 1. And so a counter is used a lot in programming, and it's as you can see, it's not highlighted or anything, which means it's not a special keyword, but it's just a kind of way for you to keep track of where you are in a program, maybe how many times you've looped through a loop, or how many times you've gone through a loop, or how many times you've done a certain action or something. So a counter is a really nice way for you to kind of keep track of certain things. And you'll definitely be using counters, later on in your programs. It's just a nice way to kind of keep track of where you are or how many times you've done a certain thing, just to kind of count how many times you've done whatever it is that you're interested in knowing. So we'll just start with our counter at 1. And what we're going to do is we're going to make a while loop. So we start with the keyword while, then we put in the brackets, and we say while our counter is less than or equal to 10. So while the value of the variable counter is less than or equal to 10, we do the following. So we have our colon here, and now we're indented. We do the following action. We print our counter, and then we're going to increment our counter by 1. So we're going to print the value of the counter, and then we're going to have our new counter value be equal to the old counter value plus 1. So the counter variable is equal to the current counter value plus 1. So let's just run this, see what happens, go through it. So we run it, we print out the values 1 through 10. What happened? Well, we start with 1, then we go into our while loop, and we say, well, while 1 is less than or equal to 10, so 1 is less than or equal to 10, and then we enter the loop. And so we print out 1, which we see here, and now our counter variable is equal to the counter variable plus 1, and so counter is currently 1, so our counter variable is equal to 1 plus 1, which is 2. And now 2 is still less than or equal to 10, so we're still inside the loop. Print out 2. Now our new counter variable is equal to counter plus 1, and now counter is equal to 2, so we do 2 plus 1, so our counter is now 3. And now we're here at 3, and 3 is less than or equal to 10, so we're still inside the loop. Print out 3, and now our new counter is equal to 3 plus 1, which is 4. And so we keep going, and then when we're at 9, so 9 is less than or equal to 10, so we print out 9, which we see here. Now our new counter variable is equal to 9 plus 1, so it's equal to 10. And now we see, 10 is still less than or equal to 10, so 10 is equal to 10. And then we print out 10, and then our new counter variable is equal to the current value, which is 10, plus 1, so now it's 11. And now that 11 is no longer less than or equal to 10, we're no longer inside this loop, and we stop. And so that's how we kind of see all the numbers between 1 through 10. So yeah, maybe let's make use of that, and let's just use this loop to sum up the numbers between 1 and 10. So we'll just start with our sum, and our sum is going to have the initial value of 0. So initially our value is 0 in the sum, and each time we go through this loop, let's add to the sum the current value of the counter. So our counter is going to take in all the numbers between 1 through 10, and each time we're going to add that value to our total sum. So our sum is going to start at 0, and then it's going to get 1 added to it, and then our counter is going to take on the value 2, and then sum is going to get 2 added onto it, so now it's 1 plus 2, so 3, and then counter is going to take on the value 3, so sum is going to have 3 added to it, so it's going to be 1 plus 2 plus 3, and so on until we reach 10. And so this is how we're going to sum up all the numbers between 1 through 10 using a while loop. And then let's just, in the end, print out the value of our sum. Let's run the code, and then let's go through it, one more time. So what happened? Well, we do the normal thing here. So we start with our counter at 1, just like above, and we enter the while loop. And 1 is less than or equal to 10, so we do the following. We print out 1, and then we add to the value sum the current value of sum, which is 0, plus the value of the counter, which is 1. So sum is now equal to 0 plus 1, which is 1. And our counter is equal to the current value of the counter, which is 1 plus 1. So our counter is equal to 1 plus 1, which is 2. And now we check, is counter still less than or equal to 10? It is. Counter is 2, so 2 is less than or equal to 10. Print out 2. Now our sum is equal to the current value of the sum, which is now 1, because we added 1 before to it. So now our sum is equal to 1 plus the current value of the counter, which is 2. So our sum is equal to 1 plus 2, which is 3. And our counter is equal to 2 plus 1. So the current value of the counter is 2, and so our counter is equal to 2 plus 1, so our counter is also equal to 3. And now we check, is 3 less than or equal to 10? It is. So we're still inside the loop. We print out 3. Our sum is equal to the current value of the sum, which is 3, plus the value of the counter, which is also 3. So we get 3 plus 3. So now our sum has the value 6. And our counter is now equal to 3, which is the current value of the counter plus 1. So now our counter is 4. And then we go through it over and over again. And then when we reach 10, so when our counter is 10, we say counter is less than or equal to 10. We print out 10. To our sum, we add the previous value of the sum plus 10. So we add all the value of the sum, and then we add 10 to that. And then our counter is going to be equal to the current value of the counter, which is 10 plus 1. And now counter is equal to 11, and so 11 is no longer less than or equal to 10. So we're not going to be inside this loop anymore. So we exit the loop, and so the last thing that we printed was 10 from the loop. And the next thing we're going to print is the value of the sum. So all the values from 1 to 10 added up, which is 55. So cool. Now we've managed to write a program that adds up all the values between 1 through 10. And now you can obviously expand this. You can say, well, I don't want to do 1 through 10. I want to do 1 through 100. So I'm going to add up all the values between 1 through 100. So while my counter is less than or equal to 100, I'm going to add that to the sum. And let's just keep the print in here just to kind of see that we really are going all the way from 1 to 100. And each time we're going to add the number to our sum. And so the value of our sum for adding, or the value of adding all the numbers between 1 and 100 is this last number here, which is the last number that we printed out, which is, so everything inside here is being printed from inside this while loop because it's our counter. So our counter takes on all the values starting at 1 all the way to 100, and we print it out every single time. And we also add this value to our sum. So we add all the numbers between 1 and 100, and what we get is 5050 as our total sum. So this is a really neat way to just kind of add up all the numbers, but it also introduces a really important concept, which is the concept of the counter. And like I said, this isn't a special variable. I'm just calling a counter, I may as well call it, like keep track or something, and then I would also have to change it here so that everything is, oops, so we write keep like this. So I'd also have to change it here, keep track, and here keep track, and here keep track, and then here again, so I'm changing my variable name from counter to keep track. And so what I've done is I've just changed my variable name, and then I had to change it everywhere, or else I would get an error telling me that I didn't define my variable before. But the point that I'm trying to make is that counter is not a special name, or it's not a special variable. It's just a kind of way for you to remember that, oh, we should capitalize the T here. It's just a very nice way for you to kind of remember that it's used to keep track of, where you are, how many, in this case, how many times have I gone through the loop. So, counter isn't a special kind of keyword or something. It's just a nice idea to keep track of how many times you've done a certain thing. And it doesn't have to be how many times have you gone through a loop, It could be like, how many times have I had a certain condition? Or how many times have I done an if statement, for example. So if you remember if statements, or if you're going to go to if statements afterwards, you can also, say every time we have an if statement, or we execute it, then, let's add our counter by 1. So let's see how many times we do this if statement, for example. So the counter is just a nice idea to kind of represent a way of keeping track of things, and it's a nice way to show this in a while loop. Okay, so let's move on to a different kind of loop maybe. Let's say, or let's deal with lists again. So let's make a list, and let's call this list letters, and let's have this list be, or let's have the variables called letters, and we'll have the list have the letters A through E. So A, and then the next element is going to be B, and the next element is going to be C, and the next element is going to be D, and the next element is going to be E. So if you don't remember, the syntax of lists is that we start and end with the square brackets, and we separate our elements by these commas. So here we have our 5 elements, A, B, C, D, E, which are each separated by commas, and they're inside of the square brackets, which indicates that it's a list. And what we're going to do is we're just gonna make an index value, and we're going to have this index value start at 0. And what we're going to do is we're going to kind of increment our index 1 by 1, and we're going to print out every element inside this list using a while loop. So let's say, well, we start our index at 0, and then let's start with the while keyword, indicating that we want to start a while loop. And now, while our index is less than the length of the list inside letters, so if you remember when we covered lists, to find the length of a list, we use the len function, and we put in our letters variable, which contains our list. So while our index is less than the length of the letters, so while our index is less than, in this case, the length of this list is how many elements are inside is 1, 2, 3, 4, 5. So while our index is less than 5, we're going to do the following. And what we're going to do is first we're going to print out our index, and next we're going to print out the element that is referred to by this index. So in the first case, we'll print out, for example, the first element. So we'll just print out the element corresponding to the certain index. And then we're just going to increment our index by 1. So let's just run this, and then let's go through it again in detail to kind of really understand. But the goal that we're doing right now is that we're printing out each element of the list 1 by 1. So let's see this in action. So we still have our output from above. Let's just comment that out so that we don't see that, and then let's run it again. So we see our index starts at 0. Now, while 0 is less than the length of the variable letters contains this list, which has 5 elements. So the length of this variable is 5. So there are 5 elements inside this list. So while the index is less than 5, while index is 0, so 0 is less than 5, so we enter the loop. We print the value of our index, print 0, Then we print the value of the element corresponding to the index. So in this case, the index is 0. So we would print out the element with index 0, which is the first element. So we remember in programming we start counting at 0. So 0, 1, 2, 3, 4. So the element with index 0 is the first element, which is A. So we print out A, and then we increment our index by 1. And now index is 1, so 1 is less than 5, so we're still inside the loop. And then we print out 1, and then we print out the element corresponding to the index 1 from the variable letters, which is B. So index 1 is the second element, which is B. So index 0, 1, so the second element. And then we increment our index by 1 again, so now our index is 3. And now, well, 3 is, or sorry, now our index is 2. So 2 is less than 5 still, so we're still inside the loop. We print out 2. Then we print out the element corresponding to the index 2 inside of our variable letters. So variable letters, element with index 2 is the third element, so 0, 1, 2. So we print out C. Then we increment index by 1 again, and then we have 4, and so 4 is still less than 5, so we print out 4. We print out, so it's 3, so 3 is still less than 5, and we print out 3. I skipped the number there. Then we print out the element with the index 3 inside this letters variable, which is D. And then we increment our index by 1, and now we're at 4, so 4 is still less than 5. We print out 4. Then we print out the element inside the variable letters, or that corresponds to this index. So the fifth element, which has the index 4, which is contained inside the variable letters. So the fifth element with index 4 is E, so 0, 1, 2, 3, 4, so the index is 4, and it's the fifth element. And then we print out E, and then we add 1 to our index again. And now our index is 5, and now 5 is no longer less than 5, so now we're no longer inside our loop. And then we exit, and then we're done. So if I, for example, started our index at, say, 4, we're only going to print out the last element, because that's the only time our index is going to be less than 5. So if we run this, we're only going to print out our index once, so index is 4. Now while 4 is less than 5, we print out 4, which we see here. Then we print out the element inside the list contained inside the variable letters with the index 4, which is the fifth element. And then we add 1 to our index, and so now 5 is no longer less than 5, so we're no longer inside the loop, so we only print out 1. And if we do index 3, for example, we're going to print out the last 2, so D and E. And if we do 5, for example, we're not going to print out anything. And that's because we're never going to enter the loop, because we say, well, while index is less than the length of the letters, so the number of elements inside the variable letters, which is 5. So while 5 is less than 5, well, 5 is not less than 5, so we're never going to enter this loop. So these are also kind of ways that you can, say how you want to start inside a loop, or if you even want to enter a loop or something, maybe you only go inside of a while loop a certain, if a certain condition is true, so like you only go inside, in this case, if your index is less than 5. So these are also kind of ways that you can structure your program later, depending on what exactly you want to do. Okay. So let's do one more thing. Let's have a really nice practical example. And let's just think of something that's high in the sky. Let's say its height is 5,000 meters in the sky, or just 5,000, and it's falling with a velocity of 50. So each step it's going to fall 50, and now it's not accelerating, so it's just falling at a certain speed. So velocity pretty much in this case would mean speed, because we're going in one direction. So you can kind of think of velocity being interchangeable with speed in this direction. And what we're going to do is we're going to do a while loop, and we're going to count the number of times, or the time it takes for our object to hit the ground. So we're going to start with 0 time, and then we're going to do a while loop. And don't worry, we'll go through all of this in detail after we run the code too. But let's just create it first, and then let's run it, and then we'll go through it again to really understand. So we start the while loop, and we do that by indicating the keyword while. We put our brackets, and then we say, well, while our height is larger than 0, so while we're above 0, and so at 0 we can kind of think of like the ground level or something, so we're 5,000, let's say meters, but it doesn't really matter in this case. Let's say we're 5,000 meters above ground, so we say 0 is ground, and we're falling at 50 meters every second. So while we're above ground, we do the following, which we indicate by the colon. Our new height is going to be equal to our current height minus the velocity that we're falling at. So each step we take 50 off of our height. So each step we're falling by 50. And what we're also going to do is our time is going to be equal to our current time plus 1. So we're going to say each second we fall by 50, and to keep track of the time, we're also going to add 1 to our time each time. And so we're going to say as long as our height is greater than 0, we're just going to keep falling, and we'll just keep track of the time. And now let's print out our height at the end, and let's print out our time. And we may notice something interesting too in a second, but let's just print this out first. Let's run it, and let's go through it in detail, and then let's understand what happened. Okay. So let's see what happened. Well, we start at 5,000, and now while our height is greater than 0, so our height is equal to 5,000, so 5,000 is greater than 0, yeah, sure. Now our new height is equal to our current height minus the velocity that we're falling at, which is 50. So our new height is equal to 5,000 minus 50, so 4,950. And we increment our time by 1. And then so while 4,950 is greater than 0, yeah, 4,950 is greater than 0, our new height is equal to our current height, which is 4,950, minus the velocity that we're falling at, which is 50. So now we're at 4,900, and we increment our time by 1. And so we're going to keep going and towing until our height is 50. So now our height is 50. So 50 is greater than 0. Now our new height is equal to our current height, which is 50, minus the velocity that we're falling at, which is 50. So 50 minus 50 is 0. And then we increment our time by 1. So our time is equal to the old time plus 1. And now our new height is 0. And so 0 is not greater than 0. So we're no longer inside the while loop. So we're going to print our final height, which is 0. And we're going to print the time it took us to reach this, or to reach this from falling, which is 100. So it took us 100 seconds to fall 5,000 meters at 50 meters per second. And it doesn't have to be meters, and it doesn't have to be seconds and all that stuff. This could be 5,000 feet, this could be 50 feet per second, or the time could be minutes, and this could be, 5,000 miles still, and this could be 50 miles a minute or something. So like, these are just numbers, and there aren't really units associated with them, but it's just to kind of convey the idea. So let's see what would happen if we change this to 49, for example, where we're going to go through the same process, and we're going to say, well, our height is 5,000, so it's greater than 0, and then our new height is equal to 5,000 minus 49, and we increment our time, and then we go through it, and then at the end, our height is our final value, and then our new height is going to be equal to our current height minus the velocity, so minus 49, and then we're going to increment time by 1, and then height's no longer going to be greater than 0, and what we see when we print our height is that it's actually 47 meters below ground, and it took us 103 seconds to reach there. So if we add 49 to negative 47, that means just a moment before we hit the ground, we were 2 meters off the ground. So at 102 seconds, we were, for example, 2 meters off the ground. And then our new height would be equal to height, which is 2, minus the velocity, which is 49. So 2 minus 49, that's minus 47. And our time is equal to 102 plus 1, which is 103. And now minus 47 is no longer greater than 0. So we print out our new height, which we have here, or our final height, and our time to get there. So this is kind of a nice way of being able to do this, but you can see that it's kind of limited in accuracy. So you kind of have to keep track of that. That, maybe you reduce your falling speed. Let's say we fall at 4.9 meters per second, and therefore we only increment by 0.1 instead of 1. And so if we run this again, now we're going to get something much closer to 0 and a time much closer to our actual falling time. And now let's say if we actually only fall by 0.49 and we only add 0.01 each time, then we're going to get more accurate again. So now we're only going to be negative 0.45 below our ground, and it took us about 102.05 seconds. And so these are also kind of ways that you can, well, first you can use this to, figure out these general problems, and then you can also kind of add accuracy. So a computer can do a lot every second, and you can really just, make your numbers smaller and make your steps smaller, and through that you can also increase your accuracy. And so in this example, for example, we had something at 5,000 units high, be that feet, be it kilometers, be it meters, be it miles, it doesn't matter, and it's falling at 0.49, and it starts at 0 time, and we're just measuring the time it takes until it hits the ground, and we're going in steps of 0.01. But it goes extremely fast because our computer can do so much every second. So it's using these kind of loops. For example, it's a really nice way to be able to calculate a lot of these things easily without having to do, a lot of math on paper or something. But while loops are a really nice thing to use. They're a great way to kind of go through something until your conditions change. So in this case, we just go through it over and over until we kind of hit the ground, or until we're no longer over the ground or something. Or here we use our while loop to go through our list until we've reached the end of our list, or until our index is equal to the number of elements in the list. And so since our index starts at 0, when the index is equal to the number of elements in the list, for example, it's going to be out of the range of the list. So if our index is 5 for a list with 5 elements, then 0, 1, 2, 3, 4, 5, then 5 would no longer be in this list. So this, for example, is a way to kind of keep track or be able to go through lists. Here we introduce the counters and adding the numbers between 1 through 100. And you'll notice here our index really is just also a counter. We just called it something different, but all we're really doing is we're just kind of keeping track of the index. So we're counting which index we're at. And here our time is also kind of a form of a counter. We're just keeping track of what time we're at right now. So these are all kind of different ways of implementing this counter principle. And so it's really nice to see, first of all, what you can do with while loops and what you can do with counters. And they're both really, really useful, and you'll probably use them a lot in programming later, and we'll definitely see them a lot in the later videos too. And you'll become very comfortable with them. You don't even have to worry about that. We'll see them again, we'll go through them again, we'll explain them again, and then you'll also be using them. So yeah, while loops and also counters that we've seen here in different forms are really kind of great parts of programming.